So, good evening, everyone. I'm Mr. Upara. I'm the founder of the ISAP and CEO of the ISAP. I work as a tutor in ISAP. Today, I'm going to teach about how to choose a research subject for your research or for your publication. So today we're going to discuss about motives and objectives of research setting and how to identify levels of evidence published in literature and defining the study group or population or sampling in a research setting, and also power calculations and how to define cases and what is meant by controls, and how to develop inclusion and exclusion criteria. And for research setting, what are the requirements, basic requirements for a research setting, and setting up a pilot phase study. And finally, how to validate your research question or hypothesis. Choosing research subject. It's very important to define your objectives of why you're choosing a research subject. There are many ways and many intentions behind starting a research. So it could be for a higher degree, or it could be simply for a publication. So you need to choose your research subject carefully. If you're planning for a higher degree, it is different. And if you're planning for a publication, it's different. So I'm going to highlight some of the common motives and objectives. In this slide, I've written, you could be part of national studies. You may be invited to participate in a national trial to collect the data for them. So that's not ideal for your own benefit, because you may get publication or you may not get publication. So if you have a job which is service oriented, then you can take up and participate in that type of research. Usually the national studies are run by research nurses who are employed specifically for that kind of research. Population-based study or community-based study, unless you got access for the database, you can't produce any meaningful evidence. The common type of studies which you can come across in day-to-day life in clinical practice are service-based studies. It may be that you want to improve the service provisions at your hospital to the cohort of the patients coming to the hospital. So usually the service-based studies are quite common as a part of audits and service improvement. So the investigating a rare problem is not easy unless you come across a rare problem. And developing new treatments could also be one of the objectives, but unfortunately you may not be part of this developing new treatments, because usually experimental studies are done by institutes and research institutes or companies, private companies. So unless you are invited to as a participant, as a principal investigator or a chief investigator, you could not be part of the developing new treatments. Tackling global crises like such as pandemic or epidemic is not that easy, and getting a publication out of that kind of research is not that easy. And you may succeed or you may not succeed. There will be a lot of competition. And it could be simply evidence synthesis, like writing up systematic reviews or conducting a meta-analysis. So in clinical practice, mainly the service-based studies are popular, and you may get an audit or a publication out of it, or a presentation at least. But if you have access to the articles, you can simply produce a lot of evidence. You can write up lots of systematic reviews and meta-analysis. So the motives or objectives of a research setting differs from individual needs. You may be opting for a higher degree, or I may be opting just for a publication. So it depends what is your requirement. So when you want to produce a meaningful paper, like if you want to produce evidence, quality evidence, you need level 1 studies or level 2 studies at least. So writing up a systematic review with level 3 and level 4 evidence is not going to benefit either yourself or may not fetch you a publication. So it's important to understand the level of evidence out there. For example, randomized controlled trials with or without concealment, without randomization could be level 1 studies. The levels 2 studies can be observation studies with control, or a cohort study, or a case control studies. So anything below level 2, if you want to conduct a systematic review with level 3 and level 4, unfortunately, you may not be able to produce a decent evidence. Best example I'll give you, idiopathic pulmonary fibrosis. Treatment of idiopathic pulmonary fibrosis does not have any level 1, level 2 evidence. So you can't register for a higher degree with that unless you are part of a new treatment trial or an experiment. So I would recommend to conduct a systematic review to find out if there's a level 1 or level 2 evidence towards your subject of interest before you proceed with that research subject. And also, when you identified your subject of interest, you need to define what is your target population, what is your study population. Target population could be elderly or younger generation. Study population is like, for example, it could be inflammatory bowel disease, or it could be FAP. And also you need to define how do you want to recruit participants. That is called sampling. The sampling techniques varies. It could be convenience sample where you pick and choose. You may pick and choose, but you may fail to recruit participants which are required for your study. You may not be able to recruit enough participants if you approach convenience sampling method. Rather, I would prefer systematic sampling. Systematic sampling is nothing but, for example, if you want to recruit pancreatitis patients from upper GI clinics, and if the upper GI clinics are happening on Monday or Thursday, you can choose those clinics and wait for the participants to come to the clinic. Or you can approach your secretary and get the hospital numbers and wait for the participants to come to the clinic. So systematic sampling usually works very well and reduces dropouts, and also you can recruit participants effectively into your trial. Random sampling is like you go into the clinics of various general surgery clinics and try to recruit participants who have got pancreatitis. This doesn't work most of the time because the participants may choose different timings and different clinics. So the random sampling usually doesn't work if you have limited time and limited resources. That's why it's very important. We need to do some power calculations and we need to identify how much sample size we need so that you can define your timelines, and also to see how much resources you need. So that's why power calculations will help you to reduce the timelines of recruitment and also appropriate management of your available resources. So if the sample is too small, there's likely chance you will end up having type 1 errors Means that you may not be produce any decent evidence towards your alternate hypothesis which you're proposing, which means that you're failing to reject a null hypothesis because of small sample size. So that's why power calculations, if possible, should be done prior to conducting a research. That can reduce timelines and also effectively manage resources. If you can't do power calculations, then at least you need to know number needed to treat. So for a pilot phase study, you can't do power calculations. So in that case, you should be in a position to calculate at least number needed to treat. So the number needed to treat comes from previous incidence rates and prevalence rates of a condition. So that's why conducting a systematic review to identify prevalence rates and incidence rates is important. At this stage, I'm not going to demonstrate power calculations, but I will, once you are into statistics, later on, I will do a demo about power calculations with various statistical modelings. But end of this PowerPoint presentation, I'm going to show you how to calculate number needed to treat, at least if you're conducting a pilot phase study. So for a pilot phase study or a clinical trial, you need to define cases and controls. What is meant by cases? What is meant by control? So to define cases, you can take the help from database of International Classification of Diseases, which is ICD-10. You have to define inclusion and exclusion criteria so that it'll reduce the timelines and also effectively recruit participants. So if you define inclusion exclusion criteria strictly, you can reduce the dropouts, you can reduce the refusals, you can reduce the losses or follow-ups. So what I'm trying to get a point is inclusion exclusion criteria is mandatory if you have limited resources and time, so that at least you can recruit an extra number of patients than required to compensate for refusals and dropouts. For example, if your sample size is 25, you can, based on inclusion and exclusion criteria, you can recruit up to 35, and you may notice refusals, dropouts, and losses or follow-ups. You can compensate. So that's why it's important to define inclusion exclusion criteria and the definition of cases. So the basic requirements of any research involves obviously how to define what is null hypothesis, what is your hypothesis, which is alternate hypothesis, and also decent evidence by reviewing the literature towards your subject of interest. And once you write a research proposal, you have to submit for R&D. And once you get R&D approval, you can submit to National Research Ethical Committee and RACE. It can take up to 3 months for National Research Ethics Committee to approve your study protocol. So that's why you need to define everything, timelines, when you would like to write a protocol and when you would like to submit the protocol and when you would like to submit for Research Ethics Committee and so on, and when you would like to recruit participants. So everything is pre-planned, especially if your resources are very limited and the time is limited. You need to plan very carefully. You need to design your project very carefully. And also, if possible, you can do statistical modeling with help of statistician or someone who has got experience in it. So these are the basic requirements of a research setting. setting up a pilot phase study. As I said earlier, power calculations are not normally possible. So therefore, you do a systematic review and find out what is the prevalence of the disease, what is the incidence of the disease, a number needed to treat you can calculate based on the prevalence and incidence. And you need to define recruitment methodology and strategy, so which should be approved by your R&D and ethics committee. And you should be able to generate leaflets and consent forms to distribute to participants. And also, while starting up your pilot phase study, you need to define your timelines and when you would like to conclude the study. It's crucial to manage your time and resources. So when you conduct your pilot phase study, you may get preliminary results. How would you like to validate your hypothesis? Number one, you can do a systematic review and produce a decent evidence towards your subject of interest and validate your research hypothesis along with your pilot phase results. Number two, you can extrapolate and do a case control trials, prospective, if you have extra time and resources. It could be randomized controlled trials, or if there are randomized controlled trials already published in literature, you can pull up all of them together and produce a decent meta-analysis. If you don't have randomized controlled trials and if the data is heterogeneous, you can still do a meta-regression on the available data in the literature and validate your research hypothesis. So the steps I've written here is either simply you can do a systematic review and validate your research hypothesis. You can conduct a prospective randomized controlled trials, or you can pull up all RCTs in literature and do a meta-analysis, or simply you do a meta-regression of all the published literature. So this is how you validate your hypothesis. So it's not just choosing your research subject, which is important. You also have to, at the end of your research, you should also be able to conclude and produce a decent evidence and validate your research question, which is important simultaneously, rather than just reporting your own results. I hope this makes sense. I would like to summarize what we have learned today. We learned about motives and objectives of a research setting and what are the acceptable objectives and motives, and how to identify the levels of evidence published in literature, and what is meant by sampling, and how to define cases, and how to develop inclusion-exclusion criteria, and what are the basic requirements of research setting, and how to set up a pilot phase study, and how to validate a research question. So what are the methodology involved we have learned today? Although in detail we haven't learned, but what are the methods or steps involved in validating research we have learned, I suppose. If any doubts, please come back to me. Thank you.